Nairobi is expanding at 4.4% every year. That represents hundreds of thousands of new urbanites pouring into the capital, creating a stark physical divide across the landscape. While the commercial downtown builds upward, the residential reality spreads outward. 61% of these urban residents live in informal settlements, housed under sprawling networks of corrugated metal. This chart shows the severity of that mismatch. On one side, the current housing supply, and on the other, an annual demand for 200,000 new units. Over a 5-year projection, that gap compounds into a deficit of over 1 million homes. To fix this, Kenya's Vision 2030 and the Affordable Housing Program are attempting a rapid transition. The goal is to replicate the mid-century housing policies of Singapore, where the government systematically replaced slums with a dense, modern metropolis. But achieving that density is impossible if a nation depends on slow, expensive building materials. Buying heavy construction supplies from abroad drains foreign currency reserves and grinds timelines to a halt. To execute this architectural leap, developers had to shift the entire assembly process, rebuilding the supply chain from the bedrock up to ensure every component is produced locally. The first stage of this new assembly model involves securing the raw foundation of the buildings themselves. Anchored by a $250 million investment from Bamburi Cement, they're constructing a massive new manufacturing plant and silo infrastructure in Kwale County. The facility is designed to manufacture clinker. Clinker is the nodular, energy-intensive precursor to cement. In the past, Kenya had to import huge amounts of it, draining foreign exchange and leaving domestic construction vulnerable to global shipping delays. This graphic illustrates how the Kwale plant shifts that balance. It increases domestic clinker capacity from 1 million to 2.6 million tons. Hitting that threshold shrinks the import volume to zero. Achieving self-sufficiency in clinker provides an insulated economic foundation. It allows the country to launch nationwide mega-projects without risking bankruptcy from global supply chain shocks. With the foundation secured, the focus shifts to the skeleton of the assembly model. Kenya is currently transitioning its metallurgical capabilities to support advanced structural steel. In the past, the local market relied on re-rolled scrap metal. While cheap, recycled scrap lacks the uniform tensile strength required to safely build high-rise towers. To solve this, heavyweights like Accurate Steel Mills and DevKey are pivoting their production lines toward virgin steel and thermomechanically treated, or TMT bars. This animation shows the difference. On the left, a standard re-rolled bar risks fracturing under stress. On the right, the virgin TMT bar absorbs and distributes massive vertical forces. This reliable supply enables architects to safely build the multi-story skeletons required for dense urban housing. By controlling the production of its own structural framework, Kenya transforms from an importer of materials into the primary metallurgical engine of East Africa. Filling out that framework requires walls, and conventional fired bricks present a major bottleneck. They are slow, ecologically destructive, and cannot meet a quota of 200,000 units a year. The solution is a disruptive hyperlocal material, the Interlocking Stabilised Soil Block, or ISSB. Instead of transporting materials from distant factories, contractors can mechanize the dirt right under their feet. Using systems like the Hydraform M10 blockyard, crews can produce over 6,000 precisely compressed blocks a day, directly on site. This 3D model shows the engineering behind the blocks. They feature a specific tongue-and-groove profile, locking into place without leaving any gap for traditional mortar. Skipping this tedious masonry work accelerates the timeline while shrinking overall construction costs by up to 40%. Using on-site soil to fill the framework makes the aggressive financial targets of the Affordable Housing Program attainable. Coordinating the rapid convergence of domestic cement, virgin steel, and thousands of soil blocks requires an invisible digital synthesizer, building information modeling. Within this software, AI-driven predictive models map every component. As you can see in this simulation, if a structural beam and plumbing lines are about to intersect, the system detects the clash and seamlessly reroutes them digitally, long before physical resources are wasted on site. Scaling this assembly line to the 730,000 planned units across 47 counties creates a localized industrial base. Over its life cycle, this domestic supply chain is projected to generate over 1 million jobs, decentralizing wealth nationwide. These completed structures stand as evidence of that industrial convergence. Kenya's architectural expansion is being engineered from sovereign clinker, domestic steel, and local soil to forge a new urban landscape.